In this video, we try to find the volume of a sphere, and we know that the volume is given by 4 pi over 3 r cubed. We know this one from elementary geometry. So to solve this one, we can do we can rotate half a circle about the x-axis or any other axis, but let's do it for simplicity about the x-axis. The first thing that we need to know is that we know the given a circle that's centered at the origin, its equation is given by x squared plus y squared is r squared. Because we want to compute the volume of a circle of a sphere that's centered at the origin, because the sphere the center doesn't play a role. The volume of the sphere depends on the radius. It doesn't depend on the center or where the sphere is located. So given this equation here, we can get the equation of the half the upper half of the circle. Let's make it symmetric, because this is not symmetric. Okay, let's assume this is the equation of the half circle. Okay, let's assume that. Okay, or let's move the center here. Let's say this is the center, the origin. So this is my equation. This is giving me the between r and minus r, the upper half of the circle. When I rotate this one about the x-axis, I rotate it, I'm gonna get the volume of the sphere. I know that in this case the volume is given by minus r ax dx. So I'm gonna integrate between minus r and r, where r is the radius, and ax I need to specify. So here it's a cross-sectional area here. So when I rotate y, I'm gonna get a circle of radius y. Okay, and if I keep adding these circles, I'm gonna get the whole volume. So ax in this case is the circle having radius y, and therefore the area of the cross-sectional area is gonna be pi y squared. I know y squared is r squared minus x squared. And this tells me that the volume is gonna be between minus r and r of, I'll take pi outside, r squared minus x squared dx. I can simplify this one more because I see that this is an even function. So I can integrate between 0 and r, and I multiply the integral by 2. So I get 2 pi, the integral between 0 and r of r squared minus x squared dx. This is just a constant, and this is just a polynomial of degree 2, so it's easy for me to integrate. So I get 2 pi times r squared x minus x cubed over 3 between 0 and r. Now when I evaluate, so I'm gonna get r cubed minus r cubed over 3. When x is 0, I'm gonna get 0. Therefore, if I simplify, I'm gonna get 2 pi times 2r cubed over 3. And this means that this is 4 pi r cubed over 3. And this is the volume that I need. So 4 pi over 3 r cubed. And this is the volume of a sphere having radius r. Okay, we see that we can do it one more time, that these cross-sectional areas are just the circles. And when we add them, so axi, where this is the cross-sectional area corresponding to this point, so axi times delta x, when I sum them, I get this formula here. And that's how I get the volume of the sphere, which is 4 pi over 3 r cubed.